Okay guys, I wanted to go over the valve selection activity with you. I've copied number 6, 7, and 8. These were the questions that most people had. What you were to do is go to the website that I attached next to this valve selection activity worksheet. And then from that, you're going to choose a valve and get manufacturer's performance data. So I opened up that link to that website. Chose the first valve that had performance data, and that was the Hunter ASV anti-siphon valve. And so I looked at that performance data, and I just copied it in here so we can look at it for the ease of answering these questions. All the other information was valid for answering number 1 through 5. And then starting with number 6, look at the performance data sheet and answer the questions below. If we were to utilize 200 1 gallon per hour emitters, what would the flow be? Well, obviously the flow is 200 gallons per hour. But when you look down here at the chart, it's expressed in gallons per minute for the flow. And so all you have to do is divide 200 by 60 and you get 3.33 gallons per minute. No matter what size valve you're using, 200 gallons per hour is 3.33 gallons per minute. And so what would the pressure loss be? Well, we come down here, we got 1 gallon per minute, 5 gallon per minute across the top for the 3/4 inch valve. So it would be something between 1 and 2 psi. Kind of towards this upper end here might be 1.6 psi. That's not an extreme pressure loss. That's very manageable and very workable in this performance data. So the next question, could you put 300 1 gallon per hour drippers on the line? Well, yeah, divided by 60 is 5 gallons per minute. We go to 5 gallon per minute for this valve. The pressure loss is 2 psi. Again, 2 psi is not going to make us reconsider the type of valve we have. When we need to reconsider is on this extreme end and on this extreme end. When we start getting up here to 20 gallons per minute, 20 gallons per minute would equate times 60. That's 1,200. If we're using 1 gallon per hour emitters, that would be 1,200 emitters. Once we have 1,200 emitters, we're starting to decrease 6 psi, and now this valve is starting to become obsolete. And what would we do? We would move up to the 1 inch valve size to increase the amount of flow that we could use. Okay, pressure loss with 24 gallon per hour heads. Okay, again, this is very low amount of flow. This is 20 times 4 is 80, divided by 60 is 1.33 gallons per minute. So obviously we're like just over 1 psi on the loss. Could you run 400? Yeah, because 400 divided by 60 is 6.6. So now we're just barely in this range. So we're safe with all these numbers that I gave you. On the other end of it, if you were only going to water 3 or 4 plants, the thing that I was getting you to think about is this valve operates between 0.25 to 30 gallons per minute, and so at this lower range, the valve wouldn't work effectively. If I was to take 0.25 and multiply it by 4 or 5 emitters, there's not enough flow going through it to get this valve to actually open up and work effectively. So you might say, you know, add more drippers, run the timer longer run the timer shorter, add more drippers, add more plants, or hey, I got 3 or 4 plants, I'm just going to water by hand. That's how you use this performance data for answering these questions 6, 7, and 8. And I will collect this from you the next time we are in class. Okay, thanks guys. Hope this helps.